Here we go. Ooh, yeah. Yep, bouncy. Definitely good. All around. You can hear that. You make music. Oh, and I got a break. All right, guys, today we're talking about CarbonX CFPC from 3DXtech. Now, this is carbon fiber reinforced polycarbonate filament, known as CFPC, and it's a fantastic printing material with great strength at higher temperatures, really nice surface finish, and it's relatively easy to print. Now, PC is often referred to as Lexan, polycarbonate, macrolon, and it's really a popular material that comes in a lot of different forms. The 3D printing filament, it can be really good for high heat applications requiring a lot of fine detail and strength, and with the carbon fiber, it's even better. This filament is ideal if you want to make a structural component that resists high temperatures, really stiff components, and something that still has great surface quality and good dimensional stability thanks to that carbon fiber. So here's the box that you get when you buy it on visionminer.com/materials. We've got this stuff in stock all day long, and it comes right here on a spool like this. Now you'll notice this particular spool is not vacuum sealed, but that's okay because you have to dry this before you print it the first time anyway. It is really nice thick material, but it doesn't always come fully vacuum sealed. Don't worry about it, it's not an issue. You can dry this and then use it regardless of if it's, you're gonna have to dry it one way or the other. Now, by the way, we are doing a comparison video of all the different carbon fiber, CF nylon, CFPC, all these different filaments, so definitely make sure you subscribe so you see when those come out. Lots more videos on the way. Now, let's talk about where you're gonna see this used in the actual real world. The automotive industry uses it a lot for fluid routing tubes, exhausts, and external parts, even interior parts. In manufacturing, it's used a lot for tooling, jigs, fixtures, even press brakes. In aerospace, it's used for bypass ducts, metal replacement tubing, and ducting, and all sorts of other stuff. But let's get into what kind of machine do you really need to print this filament? First off, your nozzle is going to have to be at 280 Celsius or above, up to 310, even 320. So your standard machine, unless you've upgraded the hot end like an Ender 3, won't quite cut it. Now the bed temperature needs to be anywhere from 110 to 120 C, and you will need an adhesive like our nanopolymer adhesive, which works from everything from PLA all the way up to PEEK. One bottle does a great job. It actually works about 100 times better than we expected when we first made it for the high temperature materials. Now, as far as the chamber temperature, you don't have to have a heated chamber, but on anything bigger than a few inches, it definitely helps a lot, especially if it's a thick or solid part. Polycarbonate does love to warp. The carbon fiber really helps keep it down, keeps that dimensional accuracy in there, so it warps less than regular polycarb, but the chamber always helps. And as far as drying the filament, yes, you absolutely must dry this filament. It is hygroscopic, meaning it absorbs moisture out of the air, and just about all of them have to be dried. Now, we do have a full drying kit available on the website with a vacuum chamber, and that is super critical and crucial in quickly drying your filament, getting it ready for the printer. Now, this is the exact stuff that we use in our shop to get the moisture out, so your prints don't get ugly and weak, and we're here to make it easy for you. That's why we also made metal spools, which are important with the carbon fiber because that stuff can get brittle and you can't always spool it around, but we've got all these little parts that make it easy. And you can also dry it at higher temperatures a little bit quicker without melting the spool they come on. Now, if you're doing dual extrusion with this stuff, it works fantastic with Aquatech X1 and Aquasys support filament, also available on our website from 3DXtech. Now, let's get into some basic material specifications. It's got a glass transition point of 143 Celsius and an HDT or heat deflection temperature of 135 Celsius. So it's definitely in the high temperature category, mainly because it can be sterilized at those temperatures. Now, the carbon fiber stuff isn't used as much in medical applications because of that carbon fiber, but you can still sterilize it. Now, some basic strength specifications. In tensile strength, you get around 70 megapascals, and a tensile modulus around 6,200 megapascals. But keep in mind, the way your part's designed, firstly, and the way it it's printed, like the orientation at which it's printed, is going to have a dramatic effect on strength in your application. You always tend to lose a little bit in the z-axis depending how it's printed, so keep that in mind. Now for all the other data, we've got all the data sheets available on our website at efficientminer.com/data, so you can find the elongation, the impact strength, and all of those other juicy details on the website. Now let's talk about some specific environmental factors. As far as UV resistance goes, it's not the best. Polycarbonate is known to yellow and break down over time, but with the carbon fiber infused, it actually absorbs a lot of that UV radiation and works pretty well. So I wouldn't worry about printing apart and leaving this outside in the sun for years at a time. As far as hydrolytic resistance goes, or how well it works underwater, if the water is cold, then it's awesome. Under 60 Celsius, you're good to go. In hot water, polycarbonate is known to break down over the year, so keep that in mind. Now, just like regular polycarbonate, it's got great resistance to greases, lubricants, oils. In alcohols, it's great for methyl, ethyl, benzyl, and butyl alcohol. Now, for acetone, it's not super resistant to acetone. You can actually smooth out parts by, rubbing it down with alcohol or with acetone or putting it in a vapor chamber, and that's actually one of the benefits of this material. Now, chlorine, it's all right. Sulfuric acid, hydrochloric acid, it's not that great. It's pretty vulnerable. So you don't want to put it in those. By the way, if this information is helping you make a decision of some kind, definitely hit that like button. It tells YouTube that, hey, our content's good and you like it and you want more of it. And while you're down there, you might as well subscribe because we've got a ton more of these videos, comment, and comparisons. In the meantime, if there's a specific test that you want us to do, we're actually going to break these parts and burn these parts here in just a second, but if there's a specific test you want to see, maybe comparing different materials, leave a comment down below. We read all the comments and we want your input. We want to see what you want to be able to make the decision for what material you need for your application. Now, let's quickly talk about some electrical properties. With the carbon fiber, this filament has a surface resistance of more than 10 to the 9th, meaning it's made it into the static dissipative category, though it's not quite fully ESD safe. Regular polycarbonate is fully insulative, so you can use it in situations where you need to insulate electronics, but the CF stuff is electrostatically dissipative, just not in the full ESD category where we get nanoparticles and carbon nanotubes and things like that. Definitely something to check out. Now let's go from here and look at some of these example parts we've got on the table. We've got a couple vases just to show off the surface quality and surface finish. And dude, this stuff is beautiful, man. This stuff comes out really, really good. If you watch our polycarbonate video, it's clear, right? So you can see through it and you see all the different textures. On this stuff, you can barely even see the layer lines. This is printed at 0.2 layer height with a 0.4 nozzle at 0.6 extrusion width. And our nozzles on our site actually have a big flat spot so you can go wider and you don't have to worry about that ratio that you see online some places. But this turned out really, really, really nice, man. Now you can see at the top of this part, you might be able to tell it got a little bit hotter than it's supposed to, and it ended up with a little bit of drooping and a slightly more, a slight sheen on the actual surface of it. So it's a little bit shiny. And that all comes into tuning. You usually don't need a cooling fan or anything like that, but every part does get tuned on these open material systems. Very, very nice. We also printed this electronics enclosure bracket, which we printed in every material for comparison, and this came out absolutely beautiful. Very, very nice part. Even the overhangs in the bottom. We printed this with support. We printed all these parts on the FunMat HT, and we used the same material for support. So there was one layer of separation at that 0.2 layer height, and it actually turned out really, really nice. You can see all the lines, they're all straight. There's not a ton of crazy drooping and things like that. It's actually really good for an undersurface using the same material as support. Now, once again, this does work with soluble supports like Aquatech X1. So if you want zero separation, you want a perfectly smooth interface, you can use a dual extruder and get great results. God, this is a beautiful part, man. Beautiful part. Even here on this really long area, this is an overhang going over supports. There's not a bunch of drooping, and it doesn't look as bad as regular polycarbonate did in that other video. Very, very nice part. We've also got this manufacturing jig right here, and it came out beautifully. It looks like we left a little bit of support in the holes. But yeah, it came out really, really nice. One of the things about carbon fiber especially for manufacturing jigs, is that it keeps the dimensional stability. So first off, what you print is what you get. Your 3D model and this, it's not going to warp a whole bunch and it's not going to be off at this area. It's going to be dimensionally stable. So you're going to get the exact specs that you wanted and it's going to stay there, especially at high temperatures. When it starts melting, you get higher temperatures out of this than you do out of the regular material. Beautiful, beautiful part. I really like the surface finish on this. We have the obligatory benchy, once again, of course, which came out amazingly well. As you can see, it is beautiful. I mean, it's just really nice. A little bit of melting up there at the top part, but the features on the inside, you can see that wheel. If you don't know, if you're not familiar with the benchy, definitely look up 3D benchy. It is a toy, but it's also a highly engineered part for torture testing 3D printers. Very, very cool stuff. If you're tuning in parts, it's a cool part to play around with. Now we've also got these sample bars here, which we have in every different material that we sell, so that if you need to test this in some sort of chemical or a temperature situation, or you're curious how this performs compared to some other materials, we've got them all. So give us a call. And we'll talk to you about your specific application, and then we'll send you several of these bars so you can test and feel some of the different materials and how they compare. We've got these available on our website. Definitely shoot us a call, let us know. Now, we're gonna go into some testing. We're gonna break some parts and burn some parts and just get it going. So let's put this over here. Safety first, safety third, whatever. Safety glasses. Sometimes this stuff explodes, especially when it's really rigid, like with the carbon fiber infusion. So I'm gonna get the handy little dandy Babco vise over there. I got my lighter ready. We're gonna start with a vase. So I'm gonna actually, let's see. I'm gonna break this one because I think it printed a little bit hotter, so it should be, nice and strong. And I'm just gonna shove my thumbs into it. This, we're gonna see the deflection, see if it bounces in and out, see where it breaks, how it breaks, if it breaks straight down the line or across the layers. We're gonna see what happens. So, the very thin wall, once again, 0.2 layer, 0.4 nozzle, 0.6 extrusion width. Let's see what happens. Here we go. Ooh, yeah. Yep, bouncy. Definitely good. All around. You can hear that. You make music. Oh, and I got a break. And it is on the layers right there. So let me do it over here again. Oh, okay. So weakest link, Z-axis for sure. Right along there. It broke pretty clean. Now it is jumping around from layer to layer. So it's not like one layer was the weakest layer. It's going up and down, probably 5 to 6, 7, 8 stair steps up and down. And very cool. Now let's test the top. So if I squeeze this, when you're at an area of a part that there's less layer cooling, meaning this is going around in circles and it's going from layer to layer to layer a lot faster in this whole area than down here. So we should get a lot better layer fusion, and this is always something that can be tuned in. We could have printed this bottom part a lot hotter, maybe faster, and it would have had a little more strength. But let's just see up here, you can see I can bend this all the way in and nothing, it's not cracking, it's not crackling. Let's see if I can, oh my God, no, this is strong. Let's see if I can break it right down the center. Ugh. Nope, pretty good. Let's get some torsion on here. Tore it apart, all right, not bad. We had some vertical breakage through the layers there, as well as there, as you can see. Very, very rigid. Definitely stronger than, it's not as malleable as the nylons. It's, yeah, definitely a little more rigid for sure. It feels stronger. It feels, I don't know, thicker. Feels thicker. So now I'm gonna break one of these sample bars. I'm just gonna bend it back and I'm gonna put it right here in the vise, and we're gonna see how it breaks. We're gonna see if it explodes, how it breaks through the little bit, the thicker wall is about, it's probably 4 millimeters thick. Here we go. Ooh, all right, all right. It was a less impactful break. We've had a couple materials in this test that exploded. We've had some that just bent and didn't break at all. This was sort of, it was more like a thud than an explosion, but it still did break pretty violently. compared to the other materials. And as we can see here, looks like the layer fusion was pretty good. We've got this break around there, and you can tell by that texture that it had very, very good layer fusion, because it's not like we have layer lines jutting out or anything like that. The bottom layer there, you can sort of see what looks like layers, but it's not a layer failure. It's just a breaking, sort of following that path a little bit. Interesting. All right, cool. All right, let's get on the flame test. Let's get some fire up in here and burn this thing. Firstly, I'm going to bring out the Print Pro 2, which comes with this fantastic little flex arm. I like to use this in the office for soldering, or you can put this over an open air printer and it will suck up the fumes and filter it out. We also have the Print Pro 3 and 4, and they do full chamber circulation. So if you have a heated chamber, you want to keep it hot and you just want it to constantly filter everything, those work great. They're pretty good. I like them a lot. They're available on our website at visionminer.com/BOFA. Love that flex arm. It's a great little tool. All right, I'm going to turn the BOFA on, and we are going to light this on fire, direct flame, and we're going to see how it lights on fire, how much it smokes, if it puts itself out, if it drips. A regular PC did have a lot of dripping. It kind of got out of hand, so I'm going to be really careful with this one. Don't try this at home unless you're really, really bored. Anyway, yeah, 10 seconds under flame. Let's see how it responds. 1, 2, 3, 4, 5. Immediate curling at 5 seconds, and boom. Not full ignition, but it's about to happen. Oh, flame. All right, we are on fire. Now notice that you see that pattern of burning that's very, very common for thermoplastics like this. And it does look, oh, it just self-extinguished. All right, not bad. Now let's do another test on the other side to see if that was self-extinguishing or if it just ran out of oomph, I guess. Oh, let me take that. All right, here we go. Test number 2. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, we got, oh yeah, we're gonna drip. We're about to drip hardcore. And boom. Let's just turn that out real quick. Got the fumes going up in the BOFA. Whoo-wee! All right. Dude. Well, it definitely dripped. Very similar to polycarbonate. Definitely lights on fire and stays on fire. Definitely not something you want exposed to open flame, especially if you're worried about burning the house down. Don't do that. Okay, so let's move right along into the thicker material. So that was a very, very thin piece. This is a thicker material, and it's actually about 3-4 millimeters thick. And I'm going to do one of the letters here first so we can see what happens to fine details when exposed to flame. And then we're going to actually light this part on fire, see what happens, see how it expands, just sort of how it burns. So let's go. And about 10 seconds. All right, so you can see it started to shrivel up a little bit and shrink up. Not bad, not bad. All right, let's let it on fire. Get a full 10 seconds. And we have almost ignition. And we're on fire. Oh, put itself out again. Let's see if we can get it to burn. Oh, it's not staying on fire much with this thicker part. Oh, there it is, kind of. Interesting. Now, it did expand a lot, sort of like we saw with the HDN CF25 from the Syntium. It sort of bubbled out as opposed to melting off. You know, with the, I believe it was PVDF, it would just layer after layer just sort of go away, whereas this expanded and, you know, bulbed out. Let's play with it and see what happens. It's definitely soft. You got some carbonization on there. Interesting. All right, not bad, not bad. Very cool. All right, so that concludes the burn test. Now leave a comment down below. Let me know exactly how you want me to test these in a future video, and we will do it. We're gonna do a bunch of cross comparisons between all these different filaments and the nylons and the carbon fibers and everything. And let us know what you wanna see down in the comments below. Now, why should you buy this from us if you're gonna buy it online? Simple, we give you 3% back on everything you order. That can go towards anything in our store, from nozzles to adhesives to build plates to machines to more filament, whatever you want. Anyway, I think that's about it for this one. Definitely leave a comment down below. Thank you so much for watching this video, and have a positive rest of your day. I'll see you on the next one.